Hi CS400. This video will cover inner classes in the context of a singly linked list implementation demo. So let's jump right in. An inner class is a class that is actually a member of another outer class, and these inner classes can access any of the private fields of that outer class. And some of the use cases of inner classes are when you have a logical grouping of classes that are kind of only used together in one place, then it makes sense to have an inner class and an outer class. And hopefully this demo will kind of clarify what I'm talking about there. So if we're thinking of a singly linked list implementation, we're going to want to have two kinds of classes. The first one is going to be the actual class for the singly linked list, and the other will be the node class that will contain the data that we want to put in our singly linked list data structure. So let's get started. I've created a Java project folder over here, and I will make a new class. This class will be the outer class, which I'll name singly linked list. And here we go. Okay, so this is our outer class that will actually represent the entire data structure. And our inner class is going to be this node class. So I'm just going to create it right now and kind of talk through it. All right. So you can see now we have two classes. We have our outer class and we have our inner class. So this is actually a private nested inner class. Nested because it's within this outer class. And for the purposes of CS400, I would recommend always setting this to private. Okay, so we can kind of use this string node as a member of our singly linked list, and hopefully that kind of makes sense as I go along. So let's just kind of work through this singly linked list implementation, and hopefully it'll kind of start to click as we go through that. So let's create a header node. So that will be our header node of type string node, which is our inner class. All right, and we'll make a constructor for the singly linked list. And we'll just have that set the head to be null. Cool. All right, so now that we have this, let's start by kind of adding in a main method, which adding in a main method is a great way to be able to just write some code quick and test out your implementation kind of as you go. All right, we got our main method in here, and let's create a new singly linked list in here. Great. So now we have this new list. What can we do with it right now? Not much. It is an empty data structure with the head node being null. All right, so let's actually build out this inner class of string node. So if we think about having a node within our data structure, what do we want to have a part of that? We want to have our data and our pointer to our next node in the list. So let's add those fields to our private nested inner class. So here you see I've created two private fields within this inner class. And let's also throw in a constructor to string node. And then we'll just have the parameter be data. And we'll kind of set it up in this way, where when we create an instance of a string node, we will set the data based on our parameter here, and we'll just set the next node to be null. We don't want to mess around with that right now. Let's then add in a method to our linked list so that we can actually add a node into the list. Otherwise, our data structure is pretty useless. So we'll add in this with we'll have to pass in some data because within this method, we're actually going to be creating a new string node and then adding it into the data structure. So let's get that started. So I'm creating a new string node called new node, and I'm calling the constructor of string node with the same parameter that will be passed into this add node method. And then let's actually add the node in once it's all created. So first we have to do a check to make sure if the list is empty, we set that up properly. Great. And otherwise, if the linked list is not empty, we will traverse through all of the nodes in the list until we get to the end and add in our new node at the end. So let's do that traversal here. And this line of code actually creates that connection between the last node in the linked list to our new node. So with that, we should be pretty good to go. So let's maybe add in some nodes to our list. So we'll add in, I don't know, an A to our list. So right now, our main method isn't helping us to test a lot since we're not actually printing anything to the console. So let's just add in this quick little print method. I just copied and pasted this in. You can take some time to kind of look through it later, but it's pretty much, the same as the add node traversal, except instead we're printing. All right. So let's see what happens if we add this node and then print the list and run it. All right, there we go. Let's try to add a couple more nodes. All right, and so we see that our singly linked list implementation is working with our inner class being the string node. So hopefully you can see through this example that it is pretty helpful to have our private nested inner class, to have our node be a private nested inner class within our singly linked list data structure. I'll get rid of this import here. I don't know what that was doing. Because really, if you think about it, this string node is not really going to be used outside of the context of this singly linked list data structure that we've just created. So there's really no reason why we shouldn't nest it in there. It kind of helps with encapsulation, makes our code a little more readable and maintainable since everything's in one place. And we have kind of all the access that we need as well. And you got a fun little singly linked list implementation kind of as a bonus in this lesson. So let me know on Piazza if you have any questions about this. I'm happy to help, or shoot me an email. And yeah, I think that's all I have for today.